Hey guys, welcome to the 85th C programming tutorial, and in this tutorial we're going to begin looking at recursion. And recursion is simply when a function calls itself. And initially this may sound like a pretty simple concept to grasp. However, once you actually get into trying to write a recursive function, you'll see that very quickly it becomes difficult to understand exactly what your code is doing. And I'm not trying to scare you or anything, I just don't want you to become discouraged if you don't really understand exactly what recursion is the first time you see it. But once you get enough exposure to it, you'll see that it really isn't that bad, and it's actually a very useful way to solve some very complex problems. So the first thing that we're actually going to be doing in this tutorial, or really the only thing that we're going to be doing in this tutorial, is writing a recursive function that will calculate the factorial of a certain number. So in case you don't know what a factorial of a number is or how to calculate it just on paper or anything, just let me go ahead and go over it really quickly. I'm sorry if you already know how to do this. So basically, to denote a factorial in mathematics, you just put some number and then an exclamation point. And this notation right here will not work in C. So if I go over here back in C and say like printf mod I or something, and then 5 exclamation point, and try and run this, that's not going to work. That will not calculate the factorial. We're going to actually have to write a function to do it. So yeah, this is just the notation for mathematics, not in C. But what 5 factorial actually is it's just simply 5 times 4 times 3 times 2 times 1. That's all it is. And therefore 1 factorial is 1, and 0 factorial is also 1. So 0 factorial is 1. And just make sure that you remember this right here. This actually isn't too hard for us to implement in our factorial function. It's just something that we should actually have in there. Alright, but now we actually got to start thinking about factorials recursively. And what I mean by that is we've got to try to break down our problem into something much smaller. So what actually is 5 factorial? Well, another way to write 5 factorial is just this. So we can say 5 factorial equals 5 times 5 minus 1 factorial, and that's, obviously 4 factorial. How is this the same? Well, 4 factorial just equals 4 times 3 times 2 times 1. And if we multiply this by 5, that would obviously become 5 factorial. And this right here is exactly how we're going to implement our function. So let me just go ahead and write it in terms of variables instead of numbers so that you can actually see how we're going to do this programmatically. So we can just say, n factorial equals n times n minus 1 factorial. And this right here is exactly how we're going to do it inside of our function recursively. So we're just going to say n times the factorial of n minus 1. And that is pretty much all there is to our factorial function. But before we actually put this code in there, we need to put an if statement saying if our number is either 1 or 0, then return 1, so that we can calculate the factorial of both 1 and 0. So we're just going to go ahead right here and write out our function. And instead of using signed numbers where they could be negative, we're not really going to deal with that. We're just going to deal with unsigned numbers, so only 0 through like 4 billion, I think, something like that, is the max value for an unsigned int. So we're just going to say unsigned int factorial. Jesus, I cannot type. And yeah, it's just going to take an unsigned int as the parameter, and we'll just call it n, just like we did in Paint right there. Okay, so the first thing that we're going to do is just calculate the factorial for 0 and 1. So if n is less than or equal to 1, then we just need to return 1. So we're going to say if n is less than or equal to 1, then just return 1. So right now, this factorial function will work perfectly for calculating the factorial of both 0 and 1. But, that's really not anything special. We need to calculate the factorial for any number. And we can just go back to Paint and look at what we did down here. So before, we figured out that the factorial of any number is equal to that number times the factorial of 1 minus that number. So this right here is exactly what we're going to be doing in our factorial function. So we're just going to say right here, return n times the factorial of n minus 1. And believe it or not, that right there is all the code that we need to calculate the factorial of a number. So let's just go ahead right here and figure out the factorial of the number 4 in Paint, and then just compare that to what our function actually calculates to see if we're doing it correctly. So we're just going to go in Paint, and alright, so we're going to say 4 factorial is equal to 4 times 3 factorial. And I'm just going to do it this way so that it's closer to what our function is actually doing instead of just writing out 4 times 3 times 2 times 1. We can all do that. We know that's 24. But let's just go ahead and write it like this and go down in steps so you can see what our function is actually doing. So, yeah. So first, it just compares n to 1. So is n less than or equal to 1? No, it's not. So it's going to come down here and do this code. So it does n, which is 4, times 3 factorial. And before it can do that multiplication, it has to calculate this 3 factorial. So it comes down here and says 3 factorial equals 3 times 2 factorial. Before it can perform this multiplication, it has to calculate 2 factorial. So it says 2 factorial equals 2 times the factorial of 1. And then it comes down here and says 1 factorial is equal to 1. And remember, it hits this if statement right here. So in this case, right here, n is 1. So is n less than or equal to 1? Well, yes it is, because n is 1. So it returns 1 right there. So now it calculated the value for 1 factorial. It comes back up here, and it does the multiplication since it already calculated the value for 1 factorial. So it does 2 times 1, which is 2. Now it calculated the value for 2 factorial. Comes back up here, and does 3 times 2. That gives us 6, so it calculated the value for 3 factorial, and then it does 6 times 4. And now it calculated the value for 4 factorial, and it returns 24, and it finally returns out of our recursive function. That's all there is to our factorial function. So let's just go ahead and call it and make sure that it works. So if we go right here and say factorial of 4, we should get 24 out onto our screen since, you know, the factorial of 4 is 24. So we run this, and yep, there we go, 24. And just one more thing that I want to point out right here is what this if statement actually is. So in, I don't want to say all recursive functions because I don't know for sure, but I'm going to say 99% of recursive functions have what's called a base case. And a base case basically allows your recursive function to stop recursing, for lack of a better term. If I didn't have this right here, our recursive function, it would just keep calling itself over and over again. It would never end. Because right here, we're just saying return n times factorial of n minus 1. It'll never perform this multiplication because it's always calculating the right-hand operand right here. So yeah, it'll never return from this function right now when we run it. Our program just stops. It just keeps recursing, and eventually it crashed because it ran out of space on the stack. And if you're not really sure what I mean by that, what it's doing right here is it's just calculating a value for n minus 1, and then it's pushing that value onto the stack, and it just keeps doing that over and over again, and eventually it just runs out of room, so the program crashes. The if statement that finally ends all the recursive calls is called your base case. And typically, whenever you're trying to solve a problem recursively, the first thing that you're going to want to do is figure out what your base case is, and then work backwards from there. So in the next tutorial, we'll see this a lot more. We'll actually be doing some more difficult recursive problems, so we can actually sort of go through the steps for solving a problem recursively. But yeah, I just thought you should be familiar with that term base case. Alright, so that's it for this tutorial, so see you guys.